Hello everyone. In the last video, we have already discussed with the cross multiplication topic and what can we do with cross multiplication for a three variable problem. We have also discussed one example of three variable problem in the previous video. If you want to watch it, can watch it on the channel. Now, in this video, we will be discussing two examples, example number two as well as example number three. In the example number two, it is kind of similar to what we have discussed in the previous video. The only catch here is that there are three variables, there are three equations. But to solve it conventional wise, like by elimination and by substitution, putting one variable value in the other equation and then solving it, it's kind of tricky as well as it can make the solving part more complicated. So to resolve that problem, we can easily use the cross multiplication method, and with the help of cross multiplication method, it will be much easier for us to solve such kind of equations. I'm reminding you once again that this is a particular case of three variable problem, and not all the three variable problems are like uh, in this manner only. Okay, so let's start enough talking. If you want to try, you can pause and then can try. Those who want to enjoy the show can continue with it. Okay, so firstly, taking the first equation, 3x square minus 2y square plus 5z square is equal to 0. And the second equation, 7x square minus 3y square minus 15z is equal to 15z square is equal to 0. Dividing both the equations by z square, we can get 3x square by z square minus 2y square by z square plus 5 is equal to 0, and 7x square by z square minus 3y square by z square minus 15 is equal to 0. As you can already observe that x square by z square, that x square by z square and y square by z square are two things which are common in both the equations, and it is a kind of two variable problem that has been converted to not exactly, so we can solve it in by taking we can solve it these equations. So what can we do is hmm, we are now having equations 3x square by z square minus 2y square by z square plus 5 is equal to 0, and the second equation, this one, 7x square minus z square my bracket 3y square by z square minus 15 equals to 0. So to solve this, I have already discussed in the previous video, we can take use of the cross multiplication method. So I can write this as x square by z square, and in the denominator I can write, or to be more precise, let's first write the formula. The formula states x square upon b1 b2 c1 c2 is equal to y square c1 c2 a1 a2 equals to z square a1 a2 b1 b2. Now just putting the values. If you want to put the values, we first need to know what are the A1, B1, C1 and A2, B2, C2. So I can write here as A1 is 3, A2 is 7, B1 is -2, B2 is -3, C1 is 5 and C2 is -15. Now continuing with this, so I can write as x square upon b1 b2, which is -2 and -3, c1 c2 5 and -15 is equal to y square. The above formula is already discussed in the previous video, right? Y square upon 5 minus 15 and z, and then after c1 c2 a1 a2, which is 3 and 7 is equal to z square upon 3 7 minus 2 minus 3. Now with that, as the name suggests, which type of method we are using? Cross multiplication. So we will cross multiply these values or multiply these values diagonally and get the answer. So it becomes x square upon minus 30, or sorry, it's plus 30 and minus of minus 15, which is 45, is equal to y square upon 35 plus 45, 80, is equal to z square minus 9 and minus of 4, minus 14, which is becomes 5. So I can say that our values becomes x square by 45, or we can solve these values further as they are getting cancelled by 5, 5 one time, 5 16 time, 5 9 times. So now x square by 9 is equal to y square by 16 is equal to z square by 1. This is the final way, or this is the final uh, step to solve the equations. We know that there are three equations and there are three variables. No doubt we can solve those equations and get the values of x, y, and z, but it would be more complicated. So we are using this ratio method, or like cross multiplication ratio method, so that it would be easier for us to calculate the values of x, y, and z. Let's assume that this is equal to some value. It is equal to some value k. Then x square becomes 9k, y square becomes 16k, and z square becomes k. Right? Now we want to substitute these values of x square, y square, and z square. But in our last equation, this one, in this equation, we are only having the x, y, and z, or we can say we are having the variables in the linear power, not in the in the power of 2 or in the quadratic, but in the linear power. So first we need to make them into linear. So I can write it as x is equal to plus minus 3 under root k, y is equal to plus minus under root 4k, and z is equal to plus minus under root k. Now, as these values are have come. So there are two set of values that has been created. The first set of values, there are two set of values that has been created. The first set of values is 3 root k, 4 root k, and root k. And the another set of values is minus 3 root k, minus 4 root k, and minus root k. So now we need to check, or we need to solve, because we need to solve these two values to get the value of k. And after getting the value of k, we will get to know that how many possible values or feasible values are there for the above equations. Substituting the value, as you want to substitute, the third equation 5x minus 4y plus 7z. Third equation is 5x minus 4y plus 7z is equal to 6. So putting the value of x, y, z, we get 5 into 3 root k minus 4 into 4 root k plus 7 into root k is equal to 6. I'm solving the first case. So what we will get is, we will be getting 15 root k minus 16 root k plus 7 root k is equal to 6, or 6 root k becomes 6, or k value comes as 1. If the k value comes as 1, then the values that we will get for our as a solution of x, y, and z will be 3 into 3 into 1, 3, 4 into 1, 4, and 1 as well, as x, y, and z. So this is the first case where we have solved and we get the values of x, y, and z as 3, 4, and 1 respectively. And you can even observe that the done method is much easier in comparison to putting or elimination or by substitution, right? Now taking the second values or second set of values, these set of values, uh, taking these values, we can say 5x minus 4y for the above equation, 4y plus 7 plus 7z is equal to 6. X is minus, y is minus as well as z. So 5 of minus root k, 4 into minus of 4 root k plus 7 of minus root k is equal to 6. So what it will become? Minus 15 root k plus 16 root k plus, sorry, minus 7 root k is equal to 6. The whole value becomes minus root k is equal to minus 6 root k is equal to 6, or root k is equal to minus 1, which is not possible, which is not possible, as the value of root k always greater than or equal to 0, but this value on the right hand side to root k comes as negative. Hence we can say that that the second case, which is is this one is not possible. Only this case is possible. So the final values of x, y, and z are 3, 4, and 1. So our answer will be our answer would be x is equal to 3, y is equal to 4, and z is equal to 1. Now, this is kind of easy, or we can say this is kind of problem that we have already practiced in the previous section, in the previous video. Let's continue with another interesting problem. Okay, so now let's continue with another interesting problem. We are given as ax. Let me zoom it. Let me zoom it a little bit. So we are given, wait, one minute. We are given this equation: ax plus by plus cz is equal to 0, and bcx plus acy plus abz is equal to 0, and then the third equation. Now, again, these are three equations. These are three equations, and there are three variables. So it is very feasible for us to solve and get the values of x, y, and z. But using substitution method or elimination method to solve these equations will be a very complicated task, to be honest. So instead of solving that, we can directly use the cross multiplication method and can get our values. How could we do that? You can pause the video and continue with solving if you want to give it a shot. Don't want to try and watch it, you're most welcome. So the first equation, ax plus by plus cz is equal to 0, and second equation, bcx plus acy plus abz is equal to 0. We will do the same thing that we have done in the earlier equations. We will divide it by one of the variable. Let's say we are taking z. So after dividing it by z, what we will be getting is ax upon z plus by upon z plus cz upon z is equal to 0, and bcx upon z plus acy upon z plus abz upon z is equal to 0. Now we will solve them. So I can say it becomes a x upon z plus b y upon z plus c is equal to 0, and this becomes bc upon z plus ac upon z, x upon z, y upon z plus ab is equal to 0. Now these two equations these two equations have transformed into the two variables, which are x upon z or y upon z. Yes, I know there are three variables in it, but we have transformed it in a form of two variable problem, and can be solved using cross multiplication method. So to solve these equations using cross multiplication, we can do what? Again, use that same formula, which is x upon b1 b2 c1 c2 is equal to y upon c1 c2 a1 a2 is equal to z upon a1 a2 b1 b2. Now just firstly we get to know that what are the values of A1 B1 C1 and A2 B2 C2. After that, we can easily substitute those values and get our answer. So firstly, we'll write down the values of A1, which is A, A2, which is BC, then B1, which is B, B2, which is AC. I'm writing these values from these two equations, from this equation and from this equation. C1 is equal to C and C2 is equal to A, B. Now let's continue. Our formula, substituting these values in our formula, x upon B1, B2, which is B upon AC, and C1, C2, which is C upon AB. It's not basically upon, just it's more of a like now convo that we used to say upon, but it's actually not in upon y divided by, in the denominator we are having C upon AB and A1 A2, which is A BC, is equal to Z upon A BC B AC. Okay, so this has been transformed into what we wanted in the formula, as we are using two equations, as we are using two equations for three variables. So we have used this concept, and then after getting the ratio of x is to y is to z, we will substitute the value of ratio in the third equation to get the values of x, y, and z. So let's solve it. As the name suggests, cross multiplication. So we will multiply them diagonally, and for y also and for z too. Now for x, I can say it becomes a b square minus a c square is equal to y upon, it becomes b c square minus b a square, and for z it becomes a square c minus b square c. I can see that there is one common constant which is present in every fraction, right? So I can take that common fraction out. In this, we are having a as the common. In this, we are having b, and in this, we are having c as the common constant. So I can write it as x upon a into b square minus c square is equal to y upon b into c square minus a square is equal to z upon c into a square minus b square. Now, so now we can calculate the ratio between x, y, and z. So x is to y is to z becomes a into b square minus c square ratio b into c square minus a square ratio c into a square minus b square. So from this we can get our values as for x, assuming it assuming this whole assuming this whole equations or system of equations equal to some constant k. Then I can say the value of x will become k into a b square minus c square. For y it becomes k into b c square minus a square, and for z it becomes k into c a square minus b square. Now this is the values that we have reached to for x, y, and z. Now substituting these values in the third equation to get the final answer. This might look a very bit longer or bit lengthy question, but it is actually not, as I am doing it by myself so that I can explain as well as I can write on with full explanation or with full details. This is appearing to be a lengthy question, but actually, if you know the concept very well, this is not a lengthy part but a very short part to get the values. For the third equation was x, y, z plus abc into a cube x plus b cube y plus c cube z is equal to 0. So we will put all these values into this equation and we will be getting x, y, z. So x, it will becomes k cube into abc b square minus c square minus a square and a square minus b square. I have just substituted the values of x, y, and z in this part, right? Substituted the values in this part plus abc into, or I can write it with different ink so that it doesn't appears to be confusing, plus abc into a cube x plus, or just substitute the values, a cube into x. The value of x is k into a into b square minus c square plus b cube, again k into b c square minus a square plus c cube k into c a square minus b square, right? So this is how we can substitute these values. Now I can sense something common. I can sense something common which is coming in between these two parts, this part and this part. So I can take those common things as k cube, as k is getting common, or further right, k cube abc into b square minus c square minus a square minus b square plus, now we will have abc and k, and it will become a to the power 4, solving this part, to the power 4 k into b square minus c square plus b to the power 4 k into c square minus a square plus c to the power 4 k into a square minus b square. Now further simplifying it, taking k and abc common, we will be getting k square into b square minus c square minus a square and a square minus b square plus abc is common, k is common, So a to the power 4 into b square minus c square plus b to the power 4 c to the power square 2 minus a square plus c 4 a square minus b square. And here we close the bracket. So this is something that we reached to, and now we need to solve it. This all is equal to 0. This all is equal to 0, right? So I can say that k square into b square minus c square minus a square minus b square plus a to the power 4 b square minus c square plus b to the power 4 c square minus a square plus c to the power 4 a square minus b square is equal to 0, right? Okay, is equal to 0. Now let's take, if you observe clearly, this whole value is complete constant, and this value is also constant but multiplied to the value of k square, which we need to calculate. So by using simple algebra, I can write as k square is equal to minus of a to the power 4 b square minus c square, taking this value to the right hand side, plus b to the power 4 c square minus a square plus c to the power 4 a square minus b square, whole divided by b square minus c square into c square minus a square into a square minus b square. Now let's multiply this minus. Let's multiply this minus in the bracket, or we could even wait. Firstly, we will solve the numerator as well as denominator. So what we will be getting is k square is equal to minus of a 4 b square minus a 4 c square plus b 4 c square minus b 4 a square plus c 4 a square minus c 4 b square, and in the denominator we will be getting, if to multiply, so it will be, let's multiply first two brackets, then we will multiply it with the third bracket. So it will come as b square c square minus a square b square minus c to the power 4 plus a square c square into a square minus b square. And then now multiplying the minus fraction in the bracket, we will be getting minus of a to the power 4 b square minus of a to the power, or plus of a to the power 4 c square minus of b to the power 4 c square plus of b to the power 4 a square minus of c to the power 4 a square plus of c to the power 4 b square, whole divided by whole divided by a square b square c square minus a to the power 4 b square minus a square c to the power 4 plus a to the power 4 c square, and then minus values of minus b square multiplied by the whole bracket, that will come as minus b to the power 4 c square plus b 4 a square minus, sorry, plus b square c to the power 4 and minus of a square b square c square h square. Okay, now I can see this value is getting cancelled by this value, and what we are left with is k square is equal to minus a to the power 4 b square plus a to the power 4 c square minus b 4 c square plus b 4 a square minus c 4 a square plus c 4 b square divided by minus of a 4 b square. Now observe closely. Minus of, or like I can say arrange it, and I can write a 4 c square, this value a 4 c square, then this value minus b 4 c square, then this value plus b 4 a square, then c 4 a square, and lastly the value which is left is this. This is already written, so the value which is left is this. So I can write this as c4 p square. You can clearly observe that what we have solved in the numerator and denominator comes out to be as 1. So I can say the whole, it gets cancelled and it comes as 1. So k square is equal to 1, or the value of k comes as to be plus minus 1. Now in the earlier part, as the value of k has come to be 1, so our values will become plus minus 1, sorry. So our values will become as x is equal to plus minus a into b square minus c square, y will become plus minus b into c square minus a square, and z will become plus minus c into a square minus b square. So our answer would be, our answer for the problem that we have discussed, the example number 3, will be x values having plus minus a into b square minus c square, y is a plus minus b into c square minus a square, and z is equal to plus minus c into a square minus b square. This will be our answer. My name is Prakhar Jain. Thank you for watching. If you like it, give a thumbs up.